Ahoy hoy, I am Planarwalk, and welcome to, I would say debate, but I get the feeling that this is going to be more of a discussion than a debate. Let me just switch over to the, this here. There we go. So yeah, this will probably be more of a discussion than a debate. When Flattening Atheism shows up, he sent me an email saying that he will probably be around, it'll be either 3 p.m. PST or 3:30 p.m. PST. So, yeah. Tim Tully says, anyone else smell a no-show? He will show up. And he's one of the more cordial flat earthers, so yeah. We've got Shills v Chills saying a lot in chat. Yeah, as if that were all said, he will show up. He's not one of these people that will... if he wasn't going to show up, I get the feeling that he would have said by now that he's not going to show up. And Shills v Shills, yeah, if you're not going to bring anything useful to the chat, I am sort of in a half mind to mute you, but not yet. But yeah, what is everyone saying right now? We've got people... What have we got? We've got people talking about... Anyone think this one will bring anything new or logical arguments? Well, the first... I should probably actually bring up the email because the topics were mentioned in that. One of the topics I'm not too solid on... Oh, he said he's ready to go. So I'll just send an email. It would have been embarrassing if I was waiting for him, but... just... Oh, there we go. And... Ahoy hoy!
Hello.
How's it going?
Hi. Doing fine.
Okay, if you want, you... What's that?
I was going to say I wasn't able to set up my mic in the room that I'm in, so I wanted to make sure you could hear me okay.
Yeah, I can hear you. I will ask chat to see how it's going for them. If you're too loud or too quiet, I might actually turn down the volume on my end because let me just see. There we go. So yeah, everyone in chat okay, you're a bit louder, so I'll just turn the... Oh, there's a reason for that. Oh, I must have had you turned up from last time or something.
Yeah, I think we had to do that.
Yeah, let me just bring up the topics. So, by the way, if you want to turn your camera on, you can. It's up to you whether you want to.
Sure, I gotta figure out. Alright.
Okay, I'll just pop this out and switch over to the setting up stream stuff.
I can't see you again, can I? I have to just open the computer.
I can... Oh, what I could do is I could start a virtual camera and then turn on camera and select the OBS camera. That should work. Maybe. Oh, there we go.
You're just being nitpicky. Oh, I guess it's staying there. Never mind.
You are very pixely, so...
Yeah, just suddenly went pixely.
Yeah. Anyway, let me just bring up the debate topics again. Okay, there are three main things that you said. The discussion about how science can't prove anything, the experiment used to determine Earth's core, the experiment used to determine the distance to the sun. And the first topic is actually very interesting to me, so... I was wondering if you could give your thoughts on that, how science can't prove anything.
Yeah, well, it's something I've heard come up quite a bit, maybe in the last, I don't know, year or two. The first time it kind of came to my attention, I think I was watching. Oh, I'm probably gonna totally butcher this. Was it MCToon and Red Pill Philosophy? Does that sound right? Am I saying those names right?
Yeah, that sounds...
I've been out of the loop for a while, so I don't know. But that's the first time I heard it come up, and then I didn't really think much of it until last time we spoke. You said it again. I was like, well, that sounds a little odd, but I just wanted to get a little more, like information about what we were talking about because... contrary to a lot of flat earthers, I'm not really in this to try to like catch anyone in like an intellectual conundrum or make someone look or feel stupid. I'm just sincerely looking for answers. I'm just not that kind of guy. And so I think I don't even remember what we were talking about exactly, but you said something like science doesn't prove anything. And so I just thought, okay, well, at the time I said, yeah, well, okay, but I just. I've always understood it to be that I guess it's a simplistic example, I suppose, but if I were to make a bizarre claim like water boils at 50 degrees Celsius, how would someone go about proving me wrong? And I would think it would be showing me a science experiment, the fully detailed, complete, measurable, verifiable, and repeatable experiment. I would say, no, your claim is false. And so that was my thoughts on it.
Yeah. So the way that science works, at least to my understanding, is you'll have, when you design experiments, you have a hypothesis and you have a null hypothesis. And just because the hypothesis, so you might have your hypothesis of water boils at 50 degrees Celsius.
Sorry.
What's that?
The hypothesis. You said hypothesis and a what?
Null hypothesis.
Oh, that would be the anti-hypothesis? Is that what you mean?
Yeah. Okay. So the way that you'd go about an experiment is you'd have an experiment, and
the reason I asked was because, at least in school for me, I never heard the term null hypothesis before in the scientific method.
Yeah, so when it comes to your null hypothesis, it's essentially what you'd expect in order to prove your hypothesis wrong. So if you said, okay, water boils at 50 degrees Celsius, right? And your null hypothesis would be it boiling at a different temperature to 50 degrees Celsius. And I'm just going to mute someone in chat because they are spamming. There we go.
I guess that's kind of inherent in the hypothesis already, isn't it? Like if you're making a hypothesis, wouldn't the null hypothesis be whatever is the opposite of what you're claiming?
In a way, sometimes it's more a bit. Sometimes it's
covering your basis or something.
Yeah. So generally, the null hypothesis is more what would you expect to see if your hypothesis is false, right? So, okay. So for example, if water let's say that I expect ice to sublimate or something, right? And so if ice sublimates, then we'd expect it to go from ice to water vapor immediately. However, if that is incorrect, what you'd expect it to see is you'd expect it to go from ice to water. And your null hypothesis would be saying, okay, well, rather than going from ice to water vapor, which it can do, right? It would be going specifically from ice to water and then potentially to water vapor afterwards.
All right.
And so that what the whole idea of science is the hypothesis is the more important part of it. As if your hypothesis is incorrect, then it can be disproven, but you can never prove your hypothesis.
So I can't prove that water boils at 100 degrees Celsius?
You can provide evidence that it does, but you can't prove it.
Then what am I doing if it boils at 100 degrees Celsius?
You are adding evidence to that it boils at 100 degrees Celsius. Now, an interesting thing that comes up when you do this is, let's say I boil water, and it doesn't boil at 100 degrees Celsius. It instead boils at, let's say, 80 degrees Celsius. Now, some people might say, well, that disproves the fact that water boils at 100 degrees Celsius. What I'd say is it disproves the fact that water always boils at 100 degrees Celsius, because actually, water doesn't always boil at 100 degrees Celsius. It can actually boil at lower temperatures if
you get higher elevation.
What's that?
At different pressures, like higher elevation and stuff, yeah.
Yeah. And so just because an experiment may show that water boils at 100 degrees Celsius, that doesn't mean that you've proven it. It just means that you've got good evidence that happens.
Right. Well, I mean, as far as gathering more evidence, I mean, we're always doing that. You don't need a science experiment to gather more evidence. I mean, a detective going out and asking people a bunch of questions isn't particularly a science experiment. They're gathering more evidence. As far as the scientific method is concerned, at least from my understanding, you're only satisfying one category of collecting data, or kind of collecting data / observation. That would be the gathering more evidence, but you know, when you involve analysis and synthesis and conclusion and all that stuff, now you're taking it to what I understood was a higher scientific level. And if let me go back a step. So if I'm saying that water boils at 50 and you do the experiment and it's at 100 or, 80, it would, depending on whatever elevation you're at, by disproving me, isn't disproving just the same thing as proving something false?
Yeah, so that's where I tend to say that. So for me, I would actually say that you can't actually disprove anything completely, right? Because there may be the small caveat that means that it's the thing that you've quote unquote disproved is actually correct. However, in the specific circumstance, there's something that you forgot to account for, or something. So otherwise, you'd get flat earthers, taking observations of something way too far away, and they see too far, and then they go, "Well, that proves that that disproves the globe model," and then you have a globe earther taking a photo of something that's dropping and saying, "Oh, that disproves the flat Earth model." Well, you've got it neither flat nor globe, so it must be a cylinder, right? And so I'd say that you can never truly prove or disprove anything. You can only give evidence for something or against something.
if you're trying to prove something universally, perhaps, like you said, if you're trying to get the end-all be-all answer. But if you were just simply trying to show me that my claim was wrong, that scientific experiment would be adequate, wouldn't it?
I would say that it's more a collection of scientific experiments is probably better than just a single experiment.
Well, yeah,
Yeah.
of course, I would hope the more people we get to do it, it just provides a little more firepower. But yeah, I mean, if you get 100 people to do the experiment and they're all showing 100 degrees Celsius is when water boils, then that would adequately prove me wrong, right? With the small, tiny caveat, of course, that someday, maybe in the future, there's something we didn't account for, right? And then now that, gives a little bit more, adds a little more to the body of knowledge to say, well, in this particular case, it does boil at 50. But in the practical sense, in the household, experiment for where most people live, yeah, I proved you wrong, is what you would say to me.
Yeah, so that is actually one of the things that I've heard a while back by someone that I disagree with on most things, actually, is that when we use the word prove, we're generally talking about not so much definitively proving something, but having enough evidence that no reasonable person would disagree with it. So, for example, if I could say I've proved that when I let this go, it will always when I let this hairbrush go, it will always fall. I've proven it. I've done it so many times that no reasonable person would disagree with me. Now that it could be wrong. It could be wrong that maybe I let this go and it just floats there for whatever reason. Maybe someone turns off gravity, but the evidence is so vast that when I let this go, it will fall, that no reasonable person is going to say, well, it hasn't been proven, or no reasonable person would say, oh, that's not going to happen.
So would it be more accurate to say then that science can't prove anything definitively, thereby, unfortunately, inherent in the practice would be this thorn in its side that ultimately we all have to use faith?
I wouldn't say that we all have to use faith. I'd say that it's the extent of evidence that you've got. So,
but we said that it'll never matter how much we add to the body of knowledge. There's always the slight chance that it could be wrong. And we can never ever definitively close that gap.
Well, I'd say that if we go by that logic, basically everything is that we think is faith-based, right? Because I cannot prove that the universe exists, right? The closest that we've got is that something exists, and this is the philosophy side of things. Like, something exists for me to be able to think. So therefore, my mind exists, at least, but I can't prove that you exist. The jury's out on you. But I act as though everything does exist because, to the best of my knowledge, that is what it seems to be.
Well, then it sounds like we agree. There's no way around it. Ultimately, there's a leap of faith.
I'd say that it still comes down to evidence. Firstly, I have to add this caveat. The way that I use faith is belief without evidence. Right? So that's the way that I use faith. You may use it a different way, as in trust. Some people use it, although... Is that the way that you're using it?
Well, if we go with yours, I'm happy to go with yours. And belief without evidence, unfortunately, sounds like it's all science experiments fall in that category. Because if there's always the possibility of adding more knowledge, to the body of work, you have to ultimately say that's good enough. At one point, we just have to say close enough. A good example is like the number pi. I mean, we literally know so little about pi, we actually can't even write it. we just have to take it out as long as it satisfies whatever we're doing with it and say, close enough.
Yeah.
We're never ever, no matter how hard we calculate, we'll never ever be able to write the number pi, which is, it sucks because I mean, I'm a math nut. I love math, but I'm like, that's always bothered me. I like the radical and irrational numbers because they obviously have a purpose and they function in the world, but we have to take faith when we use it. Now it's usually like for something that it doesn't have a lot of consequence, like if you just need to make a circle, you take it out to however many decimal places you need and it'll work. But like you said, philosophically, ultimately we have to just say, damn it, close enough.
Yeah, and I wouldn't say that it's faith to say that something's good enough to be able to use, right? Because
Absolutely.
Because
It absolutely is, because
now,
if you're never actually using the true number pi, you're not making a perfect circle, which luckily we don't really ever need, but that sucks. We will never actually create a perfect circle.
Now,
in order to
here's something that I will concede. The axioms, I suppose, that you build your beliefs on, I would say that I would concede that, yeah, those can be based on a certain faith. So I believe that the universe exists, right? Now, I have thought about this, and I cannot prove that the universe exists, because to be able to prove that the universe exists, I need to use the universe, which would be circular reasoning, right? So
Yeah.
I would say that in a way that is faith, but it's still sort of in that murky area of it's something that I take for granted, if that makes sense.
And there are a lot of things in science that if you use faith, we'll still do what we need to do. I'm not saying that, it's worth throwing out science. I'm a lover of science.
Oh, no, I didn't think you were.
What's that?
I said I didn't think you were. I didn't think
I
you were.
love science.
I was meaning I didn't think you were wanting to throw out science. That's what I was saying.
Oh, right. I mean, a lot of people accuse us of that, and just the same, I will concede that, yeah, the faith that you use in science, is something that is much more practical, in things that we need to do, like when it comes to engineering and construction and whatnot. I would not base my, construction skills or my engineering skills on what is in the Bible particularly. You know what I mean? I would use what we have here, even though our tools will never be as accurate as we would like them to be, and will never, ever, ever be accurate to perfection. But
yeah.
Anyway, I'm happy with that. If you want to go to the next one.
Yeah. So the next one was the experiment used to determine Earth's core. This is one of them ones which is rather interesting because So this is one of them ones which I know a little bit of, both the experiment used to determine Earth's core, but in the distance of the sun. I'm not an expert in these. I know a bit about them, or I know the processes used to determine it, whether you would call them an experiment, or whether you wouldn't call them an experiment is up to you. But so, what I know about how we've determined the Earth's core is using earthquakes, right? So if you have a so let's start with using something like light for an example. If you shine a light on an object, light will be reflected and you'll see the object. We can agree with that?
Yeah, I think so.
Yeah. So with Earth's core, the difference is there that we're not using light, we're using waves, or kind of like sound waves, but also different. So this comes down to S waves. I think there's L waves and P waves. You've also got other waves like PP waves, PPP waves. all these different types of waves that are at different frequencies, and they travel through the Earth. Some of them are altered. Their trajectory is altered by the Earth's core, and some aren't. And that's very much like shining light on... It's actually more akin to shining light through a prism. And you'll see, when you stand on the other side, you'll see the direction that the light has traveled, and you'll be able to calculate, okay, how much bending has happened, the refractive index of the prism due to that.
Well then, in my kind of simplistic, scientific, what I don't know what you would call it, just my first questions would be, well, number one, do we have the actual experiment to see? And number two, can we do it again? And by we, I would mean hopefully you or me or you or I could find someone who could do it for us and show everyone else. So it doesn't have to be, of course, exactly you or me. And then I want to verify that it's actually doing what it says. Like, can we do it to something else? Can we, make a big mound of dirt and put an unknown to us object inside the middle and test with the same equipment with waves and see if it can tell us, yeah, that's iron or that's aluminum or that's, I want to see how it's actually done. And I haven't been able to find that.
Yeah, so that is one of those things which is a bit... It definitely requires a bit more knowledge about what you're doing, because it's one of them things which you need to... Essentially, you need to know, okay, what is the... How do waves travel through this material, if you get what I'm saying? And...
Yeah, I mean, I'm not...
What's that?
I'm not so concerned about whether I understand how everything is working. I mean, if I was giving the experiment, I would just make it adequate for someone to watch and say, I'm going to trust that the tool is working if we can see it work on something else or a couple other things, big mound of dirt here, big mound of dirt there, whatever. However we wanted to make the experiment, put something in the middle, and the guy who says, yeah, my machine works, boom, that's aluminum, boom, that's iron, boom, that's molten steel or whatever. I want to, and they would say, yeah, you're right, it works. So now point it down and let's see what it says. And then I would be like, got it, you're right.
Yeah, so one of the things that I'd say, firstly, is we do need to wait for earthquakes, because, that is one of the main things that tells us whether these waves are, how these waves are traveling. Now, I wouldn't be able to point you to any specific experiment, but more the data, right? The data that shows, okay, this is how waves bounce off the Earth's core. And I think that it's something that I need to use my words very carefully here. It's something that I'm pretty sure there is data that is publicly available, but I'm not sure that it's in the way that you would normally consider an experiment. So you'd consider an experiment, independent variable and all that, whereas this is more data from different points on Earth, a hypothesis that the Earth has a core, and then measurements of the different ways at these points on Earth, and what that tells us about how the Earth's core would be formed, or would be shaped, or something.
Right. I mean, looking at the data would be great. I mean, looking at the data is fine. That's one part of the scientific method, but there's no room in the scientific method for, taking some dude's word for it. In fact, it's forbidden in the scientific method. So, I mean, looking at the data is good, but if we have to watch all that happen. And especially in today's world, there's really no excuse to not be able to do all this stuff live, especially if you're an organization that has, millions and millions of dollars in your budget per day, just to show us, okay, all this stuff is in the science books. Can we actually see the experiment finally?
Well,
I'm not on you, of course, but I'm just saying in general.
Well, as I
this
said,
should be done by now. Available.
Well, as I said, the data, I believe, is publicly available, or at least publicly available to the extent to which science journals are publicly available. Some of them are behind paywalls, unfortunately. Right. But you can take the data, see, go through, if you have the time, go through the papers in which the data would be in, and say, okay, does everything here match? And you'll also have to look at the references within that to make sure that, because some assumptions will be made, which will probably be talked about in the references. So when I say assumption, I'm using that word very loosely. It's more, this has been shown before, so therefore we'll just cite this. It's like if I say that I want to test the water boiling at 80 degrees or something at a different altitude, and I'm assuming that at sea level water boils at 100 degrees, right? I might reference something in my paper that says, okay, this paper says that water boils at 100 degrees Celsius at sea level. So yeah, there's that, and I might be able to try and find something right now, but it would be something that you'd probably want to go over in your own time to have a look.
Well, let's take the water boiling example. So, there's a lot of data out there that I could look up, and there could be a million papers that says, water boils at 100 degrees. And none of that data is of any use unless it's in context of the experiment. So at one point, there's going to have to be somewhere the complete experiment showing it. Otherwise, it's just a bunch of people writing it down. Which in the scientific method would be equivalent of take this dude's word for it. I mean, don't get me wrong, the data is very important. But the data, you're supposed to collect the data and then prove it. You're supposed to repeat it. I'm using the word prove, but you know what I mean. You're supposed to collect all that data and then be able to do it again, the full, complete experiment yourself. And in today's world, I would say, record it live, and a bunch of people should be able to do that.
Yeah, well, when it comes to collecting data, there's a few different ways of which you can analyze it, I guess, is a way to put it. So,
by the way, it's no interruption, by the way, but when you say data, in my mind, I'm thinking of a scientific journal, and it's a page with a bunch of numbers. That's what I think you mean by data, unless you're talking about something different.
Yeah, that is one way of putting it. So it's like, yeah, data is generally the all the information about the like in context of boiling water. Your data would be
basically the results of what you measure. Yeah.
Yeah, what you measure, and so now what was I? I was saying something before.
Sorry. Yeah.
Oh yeah, there's different ways of analyzing data. So one way of analyzing data is your classic, you don't have the data yet, and you're going to do an experiment on the data, or do an experiment to see what the data says under certain conditions. With the Earth, that's a little bit harder than just just saying, okay, yeah, we're going to shoot waves, because sometimes you can. Sometimes I do know for finding fault lines you can shoot waves. But then another way of collecting data is you have information about something, and you use that information to analyze a feature of something. So, for example, you might. Here's a great one: measuring the distance to Polaris, right? that is something that you more or less start with the data and draw your conclusions from that. So the way that we measure the distance to things like Polaris or different distances to stars is you have Earth on one side of the sun. I believe you're still a flat earther, right?
Well, I've never actually officially been one, but yeah, for the purposes of this conversation, yeah.
I'm just saying, like, this example will probably fall flat if you're a flat earther. But
okay, go ahead. I'm following.
Yeah. So you got the sun in the middle. You got Earth on one side of the sun. You take your measurements to where the star is, right? Then when we get around to the other side, you take the measurements of where the star is there, and essentially there should be a slight deviation in the angles, and you use that angle, you use the distance of the sun to calculate how much you use the distance of the sun, you double it, and then you do a bit of actually I don't think you need to double it.
Triangulation, basically.
Yeah, triangulation. And then you use that to go, okay, well, the distance to the star is this distance. Now, that is reproducible, but you can't just go, I think the distance to Polaris is 210 light years, and then do an experiment to, the prediction of how far you think it is isn't relevant when you do the experiment. The only thing that's relevant is the results that you get from the experiment. Does that make sense?
Kind of, yeah. On your earlier point about how with the Earth, you were saying with the Earth this is a lot harder. I think we were still kind of talking about when collecting data and stuff, and that's kind of what I'm trying to emphasize is that, yeah, I would agree with the Earth. It would be very difficult to figure out, like what the composition of the core is and things like that, which is why a claim of such monumental proportion would require a lot of, like fully detailed, complete experiments to watch and not just data. I mean, that's a big claim that's already being pumped in all the science books that no one really seems to have. I was kind of hoping, by talking to guys like you and other people, that someone along the way will actually have the experiment to show. And I don't want to sound like I'm placing that burden entirely on one person. I'm just saying in general, it just doesn't seem to be there. Now, when it comes to Polaris and triangulation, I would say, okay, fine. If you can do that with a star, then you should be able to do it with something else that we use. Maybe even closer, a balloon 20 miles up in the sky from different places on the Earth. And can you show me accurately that it's actually true? And that, when it comes to triangulation, you're looking at Polaris, in one part, where the Earth's on one side of the sun, and then maybe a couple months later it's somewhere else, and you get the triangulation difference in angles. You're basing that off an assumption that the Earth is a verified certain distance away from where it was before. And I want to see the experiment that now shows that you've been able to determine that we've moved that many miles away, because triangulation requires not only the deviation in the angle, but you have to know how far away you moved too.
Yeah.
So whatever experiment they use now to determine how far away the Earth moved, that's also missing. So
yeah, there are. So for that one, for determining the distance to the sun, there's a couple of ways that it has been done. I think the most accurate way is been using radar, but this is not something that any Joe Blogs can, do, because I can't shoot something into orbit around the sun, at least not at this point in time. Maybe if I get a couple $1 billion to be able to start up a space company, maybe then, but not at this current point in time. So the better way to do it, and I would actually I do know someone that has done this, and I actually did message them. I think I messaged them last night or maybe the night before, and they didn't get back to me about it. But they've been able to do this using the transit of Venus. And so the transit of Venus of the sun is something that occurs every 100 years or so, and usually happens twice. So you've got the transit of Venus. You can use the data that you collect from that to figure out, okay, what's the distance to the sun based on that?
Right. If we can use the same principle on other stuff without having, I mean, I want to see it working first and then say, okay, now that we know it's working, let's try it on Venus. Or like going back to the sun, for example, I mean, it's unfortunate, but if you know someone that's, I mean, you mentioned that, we don't have a couple $1 billion to try it out. And if the people who do have a couple $1 billion that are claiming that they're doing it and they're not showing the full complete experiment, and we know someone else who has done it, but we don't have them available to us, then unfortunately it's not science yet. It doesn't get placed in that category yet because it hasn't satisfied the scientific method.
Well, I'd actually say that. So I do put a lot of trust in peer-reviewed science. And the reason why is because peer-reviewed science, whilst it can fail sometimes, you got Andrew Wakefield, for example, who published something in, I think it was The Lancet, which is a peer-reviewed journal. However, there were so many flaws in that it was eventually retracted, right? Peer-reviewed science can fail, but the more an experiment or a series of experiments have been done, and the more papers have been published, generally the more sturdy that claim is, I'd say. And whilst, if you want...
It'll never have the credence that the actual experiment has.
What's that?
People talking about how well the experiments work, that's handy. It's nice to have around. But it'll never have the credence that the actual nuts and bolts has. Me having a camera on my pot showing it boiling at 100 degrees is way more powerful than 1,000 people saying, yeah, this guy did it and it clears. He's good.
Well, I'd actually say that, if you just have a camera on your pot or whatnot and see that it boils at 100 degrees, that is fine. That does show that the water is boiling at 100 degrees. However, scientific papers are usually far more analytical than just seeing water boiling at 100 degrees. Usually it means that the paper first has to be checked by someone else, and the second thing is that if it is reproducible, the other people have to reproduce it.
Yeah, and peer review is pretty much, I would say often satisfying the category of repeatable. Most of the time that's true. So peer review takes care of that part of the scientific method, but it doesn't cover the actual, if the actual experiment isn't there, you're not showing the observation, the data collection, the analysis, the synthesis, and all that right there for everyone to see. Peer review is very valuable stuff, and that's not even in science. That's pretty much in any subject. Peer review is most of the time preferred, but it'll never be what the actual experiment is. Well, especially if we're talking about an experiment that doesn't require really in-depth interpretation of the data, like watching water boil. You don't really need to interpret very much there, as opposed to if you're using radar or something and everything's coming back in little blips and kind of markings or something on a needle or whatever. That takes a little bit of interpretation. So then you have to examine how they're interpreting it, and then have them show you with that tool doing it on something else. This is how we interpret it. This is why we know it works this way, because we can point it at this and tell you that you're looking at a giant rock. We can point it at this, and we can with sonar or whatever, and say this is a whale.
Well, with the end goal of an experiment, I'd say, is not so much the experiment itself, but more of the data that you get from the experiment, right? Would you
say it again?
I'd say that it's the data that you get from the experiment is the important part. I
would say every category is the important part. I don't think any of them are more or less important.
Well, obviously, a well-designed experiment is also important, but the goal of it, to me at least, is the data, because using the data, you can use that to either prove or disprove a hypothesis that you may have, or you can use it to gain information about something, which actually may lead to future hypotheses that can be used to describe something. So, for example, trying to think of a good example that I haven't already used here.
Once again, I would just say you're right. I mean, collecting that data is probably, in this sense, the most important part, but it doesn't do any good if it's not in the context of the entire experiment. Somewhere, the experiment has to be available.
Yeah, well,
at one point, you're going to have to examine with the actual, meat and potatoes of how they collected that data.
Yeah, and there are different ways to collect data. Sometimes it's just waiting, and it really goes down to what you're defining as an experiment, I guess. So, for example, I would, if data has been collected about something, you've got all the numbers there, and someone goes ahead and analyzes the numbers to come up with, maybe a distance to something or or whatnot. When you've got the data there, it gets to a certain point where, yes, you could go ahead and collect that data again, because if you're doing the experiment, you're essentially collecting that data again, which can be, sometimes it can be useful to collect data again, but sometimes it's just, do you really need to? So for example, let's take, what's that?
I think I have a good example. So let's say you own a car manufacturing company, and a competitor is claiming that their car, gets twice as much fuel economy as yours, and they can say, look at all these papers. We have 200 scientists who have all this data, and they plop all these books on your table, and you go, well, damn, that's a lot of data. Can I see your car? Can I actually see it happen? That would be one of the very first questions any kind of any normal business person, I'm assuming, would ask.
Well,
at one point somewhere, the actual car has to be there.
Well, wouldn't the data, if we've got, let's use the speed of a car as an example, right? So there are two ways that you could collect this data. The first would be the computer simulations that simulate the car and trying to see what its theoretical top speed would be. But the second would be that you figure out, okay, how fast can this car actually go by driving it down a racetrack, maybe the straight of the Nürburgring, right? And then that's a more practical way of getting it. Now,
that's the one that requires less interpretation. Yeah, actually seeing it happen.
I'd say that it actually probably requires more interpretation.
To record the car actually going the speed it says it's going?
Yes, because
the company says it's going?
Because one of the things that you'll need there. So one of the thing. Okay, really good example here. So have you ever seen advertisements for wireless routers that say works up to 100 meters away or something? Yeah.
Uh-huh.
Now, a little bit of a spoiler alert, you're never going to get 100 meters away. Never. The reason being is because that 100 meters away is more of a theoretical distance. So that 100 meters away is if you are in a vacuum and there's no interference in that vacuum, then you could possibly get 100 meters away. But in practicality, you're not going to get that 100 meters away, right?
Okay.
So that 100 meters away is best possible case scenario. Now, what's that?
Go ahead. Sorry. Go ahead.
Now, if you were to actually test the router, without, just like in a normal use sense. So, like, if I were to test how far away I can get from my router before I get no signal, the distance will vary greatly depending on the day, depending on the time of day, depending on even where I am in the world. So some routers may work better, I don't know, in... what's that? Is it Denver? That's that city that's about a mile high? I think it's Denver.
I don't know, whatever.
Anyway, the router would probably work better, could possibly work better there because of less air in the way, right? But it also depends on how many walls are in the way. So there's always a bit of interpretation about it, and sometimes using the best possible case in the simulation of this can reach 100 meters in a vacuum. Obviously, if you're going to be buying the router, you're going to want to you're going to want to know, okay, this is the take this with a grain of salt. However, when it comes to doing these experiments, there are so many different variables that it sometimes is better to just do these, not so much do the actual experiment, but more of do it in a vacuum. Of course, I would prefer them to do a controlled experiment that accounts for all these variables, but yeah. Do you get where I'm coming from with that?
Well, I mean, a little bit. I don't really see how it's a really good example, but I mean, my first question would be like, okay, well, if you say it works at 100 meters, show us whatever conditions you did to make the claim that it was done at 100 meters. Let's see it.
Yeah, and that's why I do think that these, because I'm sure that these things that advertise 100 meters, I'm sure that they haven't done the experiment to make them work at 100 meters. I'm sure that at best, they've probably done some kind of experiment to say, okay, well, this can work at 100 meters if you have all the right conditions, right? However, the conditions that we've had aren't those optimal conditions, so therefore, the best case scenario cannot be achieved with what we have. If you get what I'm saying. So sometimes you've got to make inferences from the data that you do have and say, okay, well, it logically follows that if you were to reduce if you were to be in a vacuum with no light, then you'd be able to get 100 meters.
I mean, I guess if you'll allow me, it sounds like you're kind of making my point.
How so?
Well, I mean, because someone's claiming that it works at 100 meters, and you go out and you test it out and try it with a scientific experiment and say, well, no, it's not true. And they can say, well, it technically may work if you have all these right conditions. And you say, okay, well, let's see it. And they're like, well, whoops, we didn't do it. So basically, it's a lie.
Well, I think that it's reasonable to say, so for going back to your car analogy, you're trying to work out how fast a car can go, right? So theoretically, you could have some cars that reach colossal speeds of up to, I don't know, 300, let's take 300 kilometers an hour for an example. I'm pretty sure that's fast. I think they've got some cars that can even get up to 400 kilometers an hour. Now,
Yeah.
there are issues with trying to... Firstly, there are obviously safety issues with trying to get a car up to 400 kilometers an hour, but we'll ignore those issues for now. Now, the way that you'd go about determining the theoretical top speed of a car is you'd want to analyze all the different factors, like how fast is it, things like aerodynamics. So for the computer simulation, you'd want to go with aerodynamics, how its engine works, and all that kind of stuff. But in actual experimentation, you'd actually go, okay, what is the wind speed? What is the humidity, the condition, the pressure, the temperature, all those kinds of stuff. What is the track like? And then you'd take your measurements and go, okay, this is what we got. Now the car may have reached a speed of, let's say, 450 kilometers an hour, right? Now the question would become, is that the top speed of the car, right? It can reach 450 kilometers an hour, not miles an hour. But that being said, maybe that was because of a particular condition, right? So maybe it was going downhill at that point, which allowed it to reach that speed, rather than just going normally down a flat track. So you'd take all these conditions and you'd calculate, okay, under these conditions, under perfect conditions, what speed can it go? So you wouldn't take it at... You wouldn't just take, okay, this is the top speed that it can reach. Now you may say, okay, well, this can theoretically reach this top speed. We did the experiment and it reached 450 kilometers per hour. And someone might go, okay, we're going to do our experiment with the car. Oh, it didn't reach 450 kilometers an hour, so therefore it can't go. But it can reach 450 kilometers an hour. We did the experiment ourselves and found that it can go that speed. But someone else may replicate it.
Yeah, as long as they can show it.
Someone else may replicate it under different conditions, and then it doesn't reach 450 kilometers per hour, or maybe you had a particularly good driver. Now, that doesn't show that it cannot reach 450 kilometers per hour. It just shows that the top speed that it reaches typically is different than that it can reach under optimal conditions. Now...
Right, agreed. That's why you would compare the experiments and find out which one's true.
Well, you'd have two different... let's say that one experiment gives 450 kilometers an hour, and another one gives 380 kilometers per hour, right? Now...
Yeah, so you would say the one that did 450 went 450, and the one that didn't make it to 450, obviously they did something different, or they had something different to deal with. But both the experiments are there in view for us to compare. I mean, when you talk about what it can theoretically go, that's fine, but if we're getting into the topic of theoretics, we're leaving the topic of physics now. And we're saying that, okay, well then now all of Earth science as we understand it in school is theoretical and not actually what is produced in the real functional world.
Well, you can, to an extent, you can get somewhere with theoretical. So if I measure something, it would be one of them things which I can draw inferences from that. So, for example, they may have reached 450 kilometers an hour because they were going downhill. That's why it's always good to have multiple data points.
Yeah, I mean, I would think it would be kind of, I guess, an obvious an obvious condition to rule out to make sure that it's not going downhill.
Yeah. And
so that would show up in the experiment. If they were going down a mountain, then you'd be like, okay, well, that's why it's going that fast. Let's see you do it on a. The whole point of everything that we're talking about, I think, is that when you have to function in the real world as a businessman, and you want to find out if your competitor has a car that goes much faster than yours.
Yeah.
I'm sure at one point you would ultimately say, well, I want to see the car. I want to see if they're just talking a bunch of bullshit, and showing me a bunch of data on paper, or if they can actually show me it doing this, either live in person or, on video to scientific satisfaction. For me personally, I'd have like 50 videos out there and all the machinery and stuff that measures this stuff, and use that same machinery to show a different car or a different vehicle or something going at different speeds, and show the odometer live, on the motorcycle going 50, and then the radar gun that they're pointing at it, whatever they're doing. At this point, I think most people are satisfied scientifically with the radar gun. They use it in baseball and football and all kinds of stuff. They use it for just about anything to determine how fast something's going. So let's just for simplification purposes, we'll say, they're using a radar gun and they've already verified that the radar gun's working properly, blah, blah, blah. If I was, a car manufacturer, that's what would, help me determine that, this competitor does have a faster car than us.
Yeah, but if you've only got the radar gun, then you could have them, only...
Well, it doesn't have to be just the radar gun. I'm saying the experiment is satisfying scientifically, right? I just want to see it actually nuts and bolts happening, right? That's what any normal businessman would say. I want to see the actual car doing what they say it's doing. I don't want to see a bunch of documents with the guys that are just writing down numbers.
Well,
that's all fine and dandy.
Well, it's not just writing down numbers. Like, where does the actual data come from, right?
It could come from it actually being legitimate data, or it could be a bunch of people lying to try to, sell their car. That's the problem with data. You don't know if it's true or false until you see the actual meat and potato.
I think OBS... Oh, there we go. OBS disconnected and reconnected for some reason. So when it comes to... when it comes to an experiment, you'll have the... Well, when it comes to peer review, should I say, you'll have someone check to make sure that everything was, done properly.
Yeah, we've been here before.
Yeah,
we've been here before. I mean,
and then
that satisfies the repeatable part, but it's not science if we don't have the actual experiment to accompany it. It's unfortunate, but that's just the truth.
Well, the data
doesn't matter how many people agree with it.
Well, the data comes from the experiment, does it not?
Well, it might, or it could just be data. If there's no experiment to back it up to accompany it, then there's no way to verify that data is true.
Well, okay, let's use a good
I've got corruption in the world.
I've got a really good example here. So let's take let's take electron. You know how you get those images of like really small things, electron microscopes. All right, so there are ways that you could potentially fudge the numbers on that, right? However, pointing a camera at the electron microscope to make sure it's working properly isn't going to really solve that.
No, I'm not suggesting that. We're smart people. We can figure out ways of scientifically satisfying, these specific different things that come up. I'm not saying it always has to be a camera. I'm just saying whatever scientifically satisfies, the method is what we would use.
Okay, so what would you...
I've never actually examined how an electron microscope works, but I'm sure if we needed to, you and I, if we dug deep enough, we would find somewhere the actual nuts and bolts of how it was built, how it works, them trying it on different stuff and say, yeah, this is Velcro, and yeah, this is sand, and yeah, this is, mitochondria or whatever. Like, I'm sure if we dug far enough now, what's it been, 70 years or so since it's been used or something, like, we would find it, because no one's really, that I'm aware of, disputing, the merits of the electron microscope.
Yeah, so the question, I guess, comes down to at which point... So let's say I have an electron microscope, right? And I set it to work on something, and I have from that I have a whole lot of data. The data might be the images that it takes, as well as how long that it took to take those images, and all that kind of stuff. How would you go about saying, okay, show me the experiment? Like, let's say that I was only able to rent it out for, let's say 2 days.
Are there places you can go to see it working? I'm sure there's got to be some places that you can go. If you really wanted to, you could go and verify it.
Yeah, but then...
There's got to be labs in college universities that have something like it.
But then it comes down to, okay, you might be able to see the images as they're created, but then it could always be
I would walk in live.
What's
Sorry.
that?
I would walk in live streaming my experience there and showing everyone at least, what I'm seeing and the questions I ask. And, I would just do kind of an examination. Maybe I would bring an expert along with me who knows a lot more about the engineering or whatnot and have them kind of talk through it. This isn't like, it doesn't take a whole lot of, super crazy intelligence to kind of just go and check stuff out. Right?
But at that point, isn't the data more important than whatever human observation?
If it is supported by the actual experiment. Yes,
yeah,
the actual experiment has to complement it.
So the experiment being done with the electron microscope is more... In that case, I'd say that it's more to do with the data than whatever you as a person see.
Yeah, and I'm saying that if we really needed to, I'm sure if we dug far enough, we could find instructions on how to make it ourselves if we really wanted to.
Yeah, I suppose you could do that. But my point is...
This is why there's not a lot of people disputing the merits of it, because it seems legitimate to me.
Yeah, my point, I guess, is... I'd say that my point is still that the data is more important, because, you can't really... Whatever you observe... What's that?
The data is more important, but if the science experiment isn't actually there to support it, then it's not science. It's just data.
But I guess...
You're only satisfying one criteria of the method.
So But the thing is, it gets back to the point of where does the data come from? The data comes from the experiment, right?
If there's no science experiment to support it, it doesn't matter where it came from. It's just data.
Yeah. But the science experiment... So if I do a science experiment, right, I get a whole lot of data from it, and then that experiment did happen, you can come along and say, okay, well, did the experiment, where is the experiment, right? And it's like, well, I only had the electron microscope for 2 days. It's back in Otago University or something, right?
Okay.
Now, you could go ahead and I suppose you could, rent out that thing, but it doesn't make more sense to look at the data rather than, disputing the data?
Not if you want to have a strong scientific argument.
Well, if let's say there's 20 people that have all done this experiment, they've and let's say that on the 21st try the machine broke down or whatnot, right? It's just too many people to handle it, and you've got you can no longer rent that particular machine out. You can rent other machines out. 20 people have gone ahead and verified the data, right? And you want to see it reproduced. Now, you can, I suppose, rent another machine out that does the same thing. Sometimes it may be a little bit harder if you're working with LIGO, I guess. But, for simplicity's sake, 20 different experiments all confirm the same thing. And you want us to show you the experiment. We can show you the data, right? But the experiment, you'd have to, whenever you want to see the experiment, you'd have to do the experiment yourself, right?
Yeah. I mean, these are the practical pitfalls of just life. If that happens, then you're basically, your science experiment gets delayed until you can get everything back up to speed.
Okay.
That's why it takes, decades of, the body of knowledge to kind of weed all this stuff out. I mean, you say 20 people, let's say 1,000 people say that they've done it, and there's no actual experiment to prove it.
Well, if the experiment
there's nothing in the scientific method that says take these dudes' word for it.
Well, there's
nothing in the scientific method that says read this data and assume that it's gospel.
The experiment is more. I think it comes down to it's more that once something has been. This comes back down to the evidence. If let's say 100,000 scientists do a particular experiment, right? Mm-hmm. At that point, you've either every single one of those scientists are either misinformed, lying, or...
Let me answer your question this way. 100,000 scientists say that water boils at 50 degrees, and they don't have an experiment to show. One scientist says that it boils at 100 degrees and actually has the experiment to show you what's stronger.
Well, it's the scientist that has done the experiment. But my point is, if 100,000 scientists have done an experiment which shows something, right? And they've all done...
You said 100,000 scientists have done the experiment that shows something.
Yeah.
I'm interpreting that to mean that they have something to show, an actual experiment to show.
But the only... they've done the experiment, right? And the information that they've collected is the
data.
What?
Sorry. I was making a joke. I said 100,000 scientists go gather the data and then lost it. Okay.
Oh, yeah, I know what you're referring to. But, I have a really good example. All right. Okay. I remember doing an experiment back in high school in science class. What we'd do is we'd take a marble, roll it down a thing, and would use the timer, right? Now, I don't actually have the data anymore, but let's say I still had the data, right? I cannot go ahead and show you any videos of me doing this, right?
But you can do it again.
Yeah, I can do it again. Maybe not under the same conditions, but I can give you all the data that I collected, the data of how tall these things were, the sort of graph that it made. I think it made it had an interesting shape. It was.
But you could do it again, right?
Yes, if I had all the materials, I'd be able to do it again.
And you could record it today, and so I have this data, and now here, I did it back then, I don't have it for you now, but I can do it again right now and get it for you.
But I've done the experiment.
And I'm sure whatever experiment you did is recorded somewhere by some science teacher, if it was part of any ordinary curriculum.
But I've done the experiment.
I believe you.
Yeah.
It's not science without the experiment to show.
So
if I give your word for it, I'm taking it on faith that you're telling me the truth.
So it really does sound like what's being argued here is that once an experiment is done, right, and all the data is collected, you've got the data, but then the experiment suddenly evaporates up in thin air like it never happened. That sounds like what you're arguing here.
It's either that or it's false.
But if I've got
the experiment is not there.
If I've got the data, right, and the experiment has been done, I've got the data. All I've got from that experiment is the data.
The experiment has been done. That comes with a burden that you have to. I mean, you're making a claim.
Yes.
So in order to satisfy that claim, you have to actually show that it's been done.
Yes. The proof or the evidence that the experiment has been done is the data.
No, the data is the results, but it's not the proof that the experiment was done.
I said it's evidence that the evidence is the data. Now,
the only thing that you can definitively prove when you look at data is that somebody wrote it down. That's the only thing that's definitely true.
Or that a computer.
There's no way to verify that data is there because of an experiment that was done.
Well, it could be measurements that have been recorded by a computer. Like if you've if you've got
or something wrote it down. That's the only thing that we know for sure.
So, like, what would be your conditions to show that an experiment did happen?
The same thing we've been talking about. I can stick 50 cameras in my house, showing me boiling water.
So it would be
live stream, and I can have 100 friends doing the same thing.
So it would be.
I think most people would say, yeah, that experiment was done.
So it would be video.
Not always, but that you just asked me generally how I would prove something like boiling water. That would be one real good way. For the most part, most of the world, YouTube is a perfect example of this, most of the world is pretty satisfied by ordinary household video doing a regular old boring simple science experiment. And then all the data we collect, it has credence to it because you can actually watch it all happening. Or I would bring you over to my house, right? Yourself, stand you right next to me, and we would watch it happen together.
So isn't video also data? Isn't that just another form of data?
Not really. Video is more of a record. The data is the measurable results. I mean, video is more of just kind of like, I'm thinking like a courtroom, Video is the way you verify the data. I mean, you can probably submit it also as data, but not in the same sense. I mean, you don't have to have a camera to boil water, is what I mean.
But like, if I boil water and it boils at 100 degrees and I record that as data, what's the difference? Let's say I have something...
Because there's a criteria required in the scientific method of verification.
Yeah.
So the camera satisfies, in most cases, the verification category.
I would argue that actually
you can also put it in as your data if you feel like.
I'd actually...
But it's not the purpose.
I'd actually argue that the camera doesn't really verify that because there are issues with a camera. I'd say that the best thing that you've got is peer review, right? Peer review is probably one of the best things. As I said, not perfect, but works well. So if I have
we already talked about that. 100,000 scientists peer reviewing that 50 degrees is where water boils versus one scientist who shows it actually happening. All 100,000 scientists in the peer review get thrown out of the water.
Well, the issue that you've got here is that it just comes down to a numbers game, right? If all these scientists reach the same results, right, from doing the experiment, right? Sure, they may not video their experiment, but they collect the data. They have detailed descriptions of how they get the data. Other scientists can go ahead and make sure that the data lines up, and that's, to me, it seems like a far better way than videoing it, because there could be issues like a camera doesn't tell you how hot the water is. You need a thermometer or something.
The camera pointing at the thermometer does, though.
Yeah, but there are always ways in which I could develop an experiment, film it.
We're really going to split hairs on like boiling water, and if the camera is manipulating you or something. I mean, that's why I picked up a simple experiment, because you don't have to have a camera. You can just put people in your kitchen yourself and show it yourself. I'm just trying to find the easiest way.
But if you get a whole lot of people, if you get a whole lot of people in the kitchen yourself, right, and you go ahead and do the experiment, and there's a whole lot of other people there to see the experiment being carried out, and let's say it shows that water boils at 100 degrees, right?
Yeah.
And after that, what's to stop you from saying, and just say you weren't there, what's to stop you from saying, well, can you show me the experiment?
I would say you can do it yourself again right now.
So
you can either watch us do it or you can do it yourself.
So the experiment that happened suddenly sort of all that's left really is the data.
No, I'm saying when the person does it themselves, it's the same thing as finding that experiment that complements the data. It's finding the experiment. You can do it yourself if you want, or you can watch someone else do it. But either way, somewhere in the world, that experiment exists.
Well, it's more that the data is all that's left is the data, really.
No, the data is worthless without the actual nuts and bolts, without the experiment.
So let me ask you a question. Let's say that you were shown this experiment, and the experiment is over. All you have is your memories of the experiment. Isn't that just data of the experiment?
No.
Why not?
If you saw it happen yourself, I mean, just because it's in your memory, it doesn't mean the experiment doesn't exist in the real world.
But if
your memory is just a record that you can't show other people. That's why I'm saying video is basically like your memory, on display.
Although video, firstly, video can be doctored. That would be.
Yeah, we're not going to split hairs on that for this discussion, though. We're talking about verification, for boiling water, which everyone knows and has done. That's why I picked that simple experiment, because everyone knows that if you absolutely had to, you could either find it yourself or you could do it yourself.
The issue, I suppose,
thereby supporting all the data that comes out.
The issue, I suppose, comes down to when you get into really complicated stuff. I don't think that scientists that are doing the experiments you see at LIGO and that have the time to go ahead. Now, they may have the time to go ahead and reproduce simple experiments whilst they're in the university learning about the scientific method and all that kind of stuff, right? Because that is something that you do in your younger years. But when it comes to the experiment of doing very complicated stuff like LIGO, particle acceleration, all that kind of stuff.
Or the distance to the sun. Yeah.
What's that?
The distance to the sun would be a complicated experiment.
Yeah. I think that a lot of it you've got to go off the science that has been done already. The
argument that they just don't have time to verify it, that's a requirement of science.
I don't
they
think
don't have
that,
the time
I don't
think available for us, then it's not science.
It's more that I don't think that everybody that does I don't think that every scientist has the time to go through every single science experiment and do it for themselves. And
why do you think they meticulously record every single detail that they can and make it as readily available as possible? It's because they want to be the person who says that I've discovered this. What scientist would be foolish enough to find a groundbreaking discovery and not be able to make it verifiable? I mean, that's like the most annoying part of science is the amount of time and effort that goes into meticulously showing and verifying that what you did is true.
So yeah, verifying is important, right? You get you could have let's say 50 people verify that what you've done is you've used the right methodology, you've got the results.
What do you need, buddy?
Thanks.
Okay, I gotta have the door closed. Can you wait out here for me? Thank you. Go ahead.
So let's say you've got 50 people that come along and verify, make sure that your methodology is correct. They meticulously go through your paper, try and find any particular flaws that might have occurred. They make sure that there's no conflict of interest or anything. They make sure that then they reproduce they may even reproduce what you've done if they can, if that is available to them. And then...
Yeah, I get where you're going here. And I'm saying that only a fool would peer review a paper and not actually look at the experiment themselves. Only a fool would go through that amount of time going through all this data and all of the stuff that you're talking about and not actually just check.
Well,
maybe it's a difference in opinion of what we think is the most important criteria. You say it's data collection. I would say it's verification. I would say after all that work is done, let's just check if it's true.
Well, it comes down to whether they can repeat the experiment. Like when it comes to the distance to the sun, the transit of Venus only happens every so often, right? You've only got a window of time. That's why it comes down.
We haven't even seen the experiment that they did. I mean, the claim that it's only a bit, possible to do a couple times. That's fine. Well, can we see the first one?
Well, you can't really see the transit of Venus, unless it's during a transit of Venus. Some people might have taken videos, but video is a very recent thing. You going way back to the I think it was the either 17th or 18th century. They didn't have videos back then. All they had was...
Okay, has it been done since?
What's that?
Have they verified since?
Oh yeah, it's been done again, but it's more...
Okay, can we see those?
What?
Can we see those?
You'd be able to see see video, but the issue that you've got there is that just seeing a video of the transit of Venus doesn't tell you everything.
Experiment. I'm talking about the experiment. I want to see the experiment happen. Whatever they did to collect the data,
they would have gone ahead, used particular instruments to see it. Now, I don't think that every scientist is taking video of every little thing that they're doing when recording an experiment.
Every scientist that I know does that.
I can ask AB Science, because AB Science is actually in the chat. He's a physicist.
I mean, if you were doing like a doctoral thesis or something, wouldn't you have some? Wouldn't you have something that kind of walks you through the entire experiment, like showing everyone what you were doing?
Isn't that the point of the paper? That the paper
details show the experiment.
The paper details what you are doing, right? And it'll show what you are doing, how you did it, and the data that you got from it.
Right. So if I can't repeat that myself, then I want to see who the person who can.
And if a experiment that's been detailed in a paper has been reproduced by people that have peer-reviewed it and gone through and said, okay,
can I see one of those people do it? That's the whole issue when it comes to the
paper. The paper is basically the record of what they've done, though. AB Science asked, "What was the question?" And the question is, "Do you video everything that you do?" I'm just asking AB Science. He's in the chat. He's the scientist that I was referring to.
And again, I'm not saying it always has to be video. If it's something that everyone can do themselves or something that another person can do themselves, is it possible for them to verify it either by video or having a bunch of people around them or doing it themselves and showing a bunch of other people how they can do it themselves or telling a bunch of other people how they can do it themselves?
Well, isn't that the point of
measuring the distance to the sun? I don't see any of that.
Well,
I don't see the experiment itself. I don't see the details on how we could do it ourselves or how anyone else can do it themselves and verify that they're actually doing what they say they're doing.
Isn't I'm pretty sure that just about every paper that is published has multiple authors on it. So
doesn't matter.
You'd have multiple authors, and when I mean multiple authors, it's people that have accompanied you when either gathering the data.
One author, 10 authors, 100 authors. If it can be redone, then it's fine. That's what I'm saying. If it can be done by you or me, or you or I can find someone else who can do it, then all good. Then we're using science. But if there's no experiment that exists and there's no details on for us to do the experiment ourselves or find someone else who can do the experiment, then it's not science.
But the thing is,
it might be very, exciting material, but it's not science.
The experiment has, when an experiment has already been done, and peer review is usually what's redoing repeating the experiment, because that's what they can do, right? Why do you and I need to do it? Can't it be enough?
Because that's the part of the scientific method required to be able to repeat it.
That would mean that nothing can be accepted unless, if, let's say, science finds that, I don't know, let's say that science finds that, I don't know, it's a really healthy option for everything. There's something that you do that's really healthy, or no, actually, better yet, something that you shouldn't do, right? Let's say that science says you shouldn't. Yeah, smoking, really good example, right? Now, you could you could either do it yourself, right? You could either do an experiment yourself, which would probably be unethical to say, okay, let's get a whole lot of people to smoke and a whole lot of people to not smoke. Or you can...
Irrelevant. Whether it's ethical or not doesn't matter whether it's true.
Well, it does come down to, if you're intentionally harming someone for the sake of an...
But then we're not talking about science. We're talking about intention and motivation.
Well, if you're likely to harm someone, I think for the purposes of an experiment, then
so smoking makes you healthy.
You're telling people, okay, you're a perfectly healthy person. We need you to start smoking. That may end up killing you or causing bad impacts. It's neither here or there, though. The point is, I don't think everyone needs to replicate that. Now you could say, okay, let's...
Are you under the impression that I was suggesting everyone needs to replicate that?
Well, okay, let's say that you find someone who can replicate that, right? I don't think that you need to find someone that can replicate that if there's been papers that have been produced that show the link between...
my point is, if you're making the outrageous claim that smoking makes you healthier, well, someone's going to want to see the actual experiment.
Well, I'm more saying not the claim that smoking makes you healthier, but the claim that smoking can cause cancer.
Well, let's take the one that actually happened, in the 50s, where they said smoking would help you lose weight, right? That was a perfect example of peer-reviewed people who were basically paid and it was conspired with the cigarette companies to say that smoking will help you lose weight, right? And no one ever actually checked, right? It was just
and
everyone just said, "Well, here's the data,"
and and you can go ahead and review old science to see, does it still hold up, right? But my issue would be, you've got all these experiments that have been done, right? And unless, take something that's been done in the 50s that, kind of everyone just assumes because it's so much of a staple, do we need to go ahead and redo it because there's no videos or because I haven't done it? I haven't done an experiment that...
Science, yes.
What's that?
If you want to call it science, yes, because science can't be purchased with money. And so if I had a whole bunch of money and I just wanted to pay off a bunch of authorities and scientific geniuses to say that smoking cures cancer, I could get a whole bunch of authorities to write it down and pay them off. But if there's no actual experiment, that shows that what I'm saying is true. It's just a bunch of authorities circle jerking each other through peer reviews, that are paid off to say that, and then it's just a bunch of data. If I don't actually have to show you like what's going on in the lungs or whatever is happening to someone who had cancer and the cancer was eliminated because of smoking, it's not science.
Well, it's more about. So I'm going to use the whole smoking causes cancer kind of thing, right? So,
all right.
One of the huge reasons why I don't smoke is because there's a lot of data that suggests that smoking causes cancer, right?
And a lot of scientific experiments that show that the data is true.
However, how do I know that those scientific experiments are real? Like that,
because you can do it yourself, or you can find the person who did the experiment. I'm sure if we looked hard enough, we would find somewhere someone doing the full experiment with the MRI or the equipment that they use, for cancer research to show that, yeah, this person smoked for 20 years and this is what we discovered happened because of it.
Wouldn't that be?
You could actually watch the whole thing happen.
Wouldn't that be the data, though? Wouldn't that just be...
No, that's the experiment. The data is what you write down on paper.
Okay, what
of all the stuff
is... So what actually shows the experiment?
Like I said, you can record it if you want on video. You can bring a bunch of people in and watch, and observe it together. Like there's a handful of different ways of doing the actual, the hypothesis, the observation, the analysis, the synthesis, all that stuff. That's all the experiment. The full, complete experiment involves data collection, but also all these other required, criteria.
So I very much doubt that any of the experiments which showed that, smoking causes cancer. I very much doubt that there were videos of those things. Now, the second thing would be, getting other people.
If you wanted to, could you go into a lab if you really wanted to? I don't know, it might cost you a couple $100 or something, whatever it would require. Go to a lab technician or assistant or a doctor, and for educational purposes, they would walk you through what they do, bring in a cancer patient, whatever, you get clearance for all of it to happen. I mean, science experiments are kind of annoying because you got to do all these other little details. But if you really needed to, you could actually create the experiment yourself, again, if it's not already there.
I mean, yes, you can, but my point is more...
Sorry.
Okay. I'm gonna just see what the chat's saying. Please ask this guy straight.
Sorry, guys. I got kids that are waking up, and I don't know how much longer I can keep them entertained on their own.
Fair enough. So
I'll go as long as I can, I suppose, but they keep bugging me.
Yeah, I've probably only got an hour and a quarter because I think in an hour and a quarter we get the COVID updates. We've got Delta in the country, and at 1 p.m. there's always a COVID update to just let us know how many new cases and all that. Anyway, back to the
stops your stream. Does that stop your stream when that happens?
What's that?
And that stops your stream when that happens?
Oh no, it's more of I want to watch it myself.
Oh, I see.
Yeah.
Okay.
So getting back to the discussion. So someone could walk you through it, I guess, but the point is, like, why would you go to all that trouble to redo it yourself? Like, I could go ahead and... What?
Because I want to check.
Okay.
I have the scientific integrity to actually check and see if they're full of crap or not.
So have you gone ahead and checked to see whether smoking causes cancer?
No,
So
but I'm not disputing that either. I mean, we're talking about in situations in which things are disputed, like the nature of the physical Earth. But yeah,
so my
but I do feel very confident that if I had to, I could find the experiments that show that it's true.
so I'm just thinking because so why don't you dispute? Hold on, here's a good question. Why do you dispute the shape of the Earth, but you don't dispute things like smoking causing cancer?
Well, like we've been talking about, I came to you because I had questions like, where's the experiment that shows, what the composition of the Earth's core, or distance to the sun, or science doesn't prove anything. Like those questions are kind of thorns in my side when it comes to the shape of the Earth. I don't have a big thorn in my side of how smoking causes cancer, because a lot of people die from cancer who are smoking, and there's at least a good there's a good preponderance of evidence pointing in that direction where I haven't felt compelled to deny it. But,
Okay, so
yeah.
why do you? So my question would be like, why do you feel compelled to deny the scientific consensus on the shape of the Earth?
I feel like I'm being lied to when it comes to smoking cigarettes causes cancer, and I do feel like I'm being lied to when we're told the nature of the physical world that we live on.
So really, it comes down to you feel like you're being lied to about one thing, but you don't feel like you're being lied to about another thing.
Yeah.
Okay, I don't think that that's a good reason to question something. Like so the way that I question things, because there are things that are worth questioning.
I'll be there soon. Go ahead.
So yeah, the way that I go about questioning things, like if I
And the reason why we check out anything, really, why we question anything, or why we challenge anything, is when we do feel like we're being lied to, or when we do feel like we're being fed BS. I mean, that's kind of one of the mostly why people question and challenge stuff.
yeah, but when it comes down to your video is hardcore bugging out. Are you there? Okay.
Sorry, give me a second.
Okay. So AB Science says his argument feel like I'm being lied to, but I will accept data which can be repeatable through experimentation, apart from all the data that I can repeat through experimentation. Okay, so are you there?
Yeah.
Okay. So yeah, it really comes down to I think it really comes down to your feelings about whether you feel like you're being lied to. I do not like to use feelings.
The more accurate way to say it is I'm in the pursuit of truth. It's not so much I feel like I'm being lied to. I mean, that's a part of the puzzle. But just generally speaking, I'm in pursuit of truth. And I don't see a lot of discrepancy when it comes to smoking causing cancer.
Yeah,
If that helps at all.
So why do you see more discrepancy when it comes to so why do you see more discrepancy when it comes to the shape of the Earth rather than smoking causing cancer?
Because there doesn't seem to be any actual experiments that are supporting the data regarding the spherical spinning Earth, just like we were talking about today. And then when you include like the back and forth battle that's been going on for the last 5 or 6 years or something with all this stuff that's being introduced, it raises a lot of questions.
Okay.
For me, and then what I would consider anybody who has kind of a, open mind enough to look into it.
So, so I could argue with what experiments do you have for smoking causing cancer?
Well, there's a lot of people who have died, who are smokers, who died of cancer. There's a plethora of, pictures and not pictures so much, but like education in schools that, go into the details of what happens in the human body when certain chemicals are introduced, and there's a lot of information that seems to in the real world be manifesting when you see a smoker and they've been smoking for 25 years and they're hacking out their lung just by walking up a flight of stairs. You can put a lot of stuff together that way.
But isn't that more data rather than actual experimentation?
Yes, but like I said, if I had to, I could go and actually find the experiments that showed all this stuff happening in the body. And you could too, and I'm sure a lot of other people, if they really dug hard enough, which I don't even think would really take that long, maybe a week or two, to find the actual, experiment being done, not the data collected and written down, but the full experiment hypothesis, observation, data collection, analysis, synthesis, conclusion, and whatever else, part of the criteria is that I forgot to mention. You could see that somewhere, and if you couldn't, you could find the person who did do it, or find people who are still doing it today, and do it with them.
That sounds
scientific. It sounds boring and annoying and really long.
No, it's more
arduous.
It's more that it's more that how do I put this? Like what you bring up here, like firstly you brought up the people having died from smoking. Like that is data. Like you talk about going and finding the experiment. Why haven't you questioned whether there is an experiment yet about that, but you have questioned about the shape of the Earth? You
go back a few minutes and I'll give you the answer again. It's the same thing as before. Yeah.
Like the whole thing about you can find details about processes, about what's going on in the body. That is true, you can. But you can also find detailed processes about what's going on with Earth, like what's going on in space.
That's what I came to you today for, about the actual experiment that shows the sun being 90 million miles away, the Earth's core's composition. And we did, I wrote here as a kind of a scratch note, how they figured out how deep the core actually is and all that stuff. Like, you gave me some information about things some guys have done and what they talked about and stuff, but the actual experiment, that's what we need. That's the part that's missing.
I'd say that it's more about the method of data collection. To be perfectly honest with you, I need you, right, to define an experiment for me, please. Like, just define what constitutes an experiment.
The fully detailed, complete, measurable, verifiable, and repeatable experiment satisfying the scientific method of which the criteria are, and I might not get all of them, but hypothesis, observation, data collection, analysis, synthesis, verification, and conclusion.
Okay. So, there has been things done when it comes to let's say the core, for example, right? There has been observation, like the observation, or the hypothesis would be, I actually am not certain of what the hypothesis was there, but the observation...
That's okay. I gotta run soon anyway, but just go back to a science class in high school. You didn't get an A unless you did all those unless you satisfied all that criteria. You know what I mean? It was annoying. You had to go through all this work.
Yes.
And, you had to do the whole experiment.
However, the issue comes down to did you take any videos in science class?
Sometimes.
Okay, I never did. I do not remember taking any videos. The best that I could... we had, especially seeing as some of the experiments that we did, especially when it came to osmosis, I think it was.
I'll tell you this one that I did if you want to know. I did the simple one where you have a pan of water and you put a bunch of pepper in there and you stick soap on one side. Have you ever done that one?
I don't remember that one.
So you stick a bar of soap in the water on one side and all the pepper goes to the other side. So my teacher believed me that I did the experiment, but she said, you got to record it at home. I want to see you do it. I want to actually make sure you did the experiment. Now, in this case, it was for the grade to make sure I wasn't slacking off or whatnot, but the same principle applies. I want to see you actually on your kitchen table with a pot of water, take the 13, 14 seconds or whatever to stick the soap in and show me that you did it.
Okay, so the issue comes
down... I could have just gone home and typed it out on a piece of paper and not done the experiment.
Well, the issue here is, if you do the experiment, right, there's multiple ways of recording it. You could record the information that you get from the experiment. Now, if you are just making the information up, what's going to happen is your teacher would go, okay, well, they can either do the experiment themselves, which would be a form of peer review, right? Or they can check it against the other students, right? If all the students in your class get, let's say, they get a result of, it took 5 minutes...
Sorry, I need to stop there.
What's that?
Just because I have to go. But, I mean, the point of the recording was to verify that I did it, not so much to, get the data.
Well, that would be...
So, video happens to be a really good way. It's not perfect, but it's,
wouldn't be
the best ways to verify something like that.
Wouldn't recording the information also be a good way of recording that you've actually done it? If your data matches what other people's data is...
You can double dip and actually... Yeah, you can still consider data and double dip the verification and the data. And so what I'm saying is you have to have that. If you're double dipping, that's fine, but at least you have the experiment.
Yeah, so that when your method of recording that you've actually done the experiment is just recording the data, and by recording the data I mean taking for example, when it comes to the osmosis thing, we had to get little cores out of not cores, but little bits of potato. We had to measure the weight of them, we had to measure the volume of them, all that kind of stuff, right? And the evidence that we did the experiment was actually more the data that we wrote down afterwards. Because if that data didn't... If one person's data...
based on trust, because your teacher trusted you, but not because it was scientific.
Well, if I just wrote down random numbers, right? If I wrote down random numbers, that would look really sus.
Not random numbers.
What? What's that?
Doesn't mean it's not proof that you did it.
Well, if I were to write down random numbers, now let's say that someone else, let's say that I wrote down random numbers and it just so happened to track with what everyone else was saying. Okay, maybe I got lucky, but the chances of me getting lucky are very, very small. The chances of me getting lucky for my random numbers to match with everyone else is very, very tiny. Wouldn't you agree with that?
So what? The experiment.
Yeah,
even if you
But the thing
And
is,
there's so many ways you can go about it. You can just find someone who did the experiment and copy their page and turn it in and say you did it yourself.
yeah, and the point is that the experiment, in that case, like someone has done the experiment.
Exactly my point.
Yeah, and
Then you should be able to find it or do it yourself.
like if everyone does, like let's say that everyone does the experiment at home, right? And at the end of the day, the teacher really has the only evidence they have that people actually did the experiment was the if it's written down, it's the data that they've written down, right?
Okay.
So, like, and if someone's data doesn't matches up, right? That means that there's that something's gone. Like if 50% of the, like 90% of the class's data matches up and one person's data doesn't, which data are you going to say is correct?
With the person who can show me the experiment. I'm not going to believe the 90% just because they all agree. I'll say, okay, yours is off, so let me see you do it.
Yeah, so
That guy and say, okay.
So you'd question.
Let me see if you're full of crap.
So you'd question the person that you'd be more likely to put.
No, I'd question both of them. I would stick with the 90% guy and 10% guy and say, okay, you guys, there's a dispute here.
Yeah, and what if the I'm just. But like, wouldn't all these people doing that have done the experiment, like, let's say that the teacher comes along, right, does the experiment and says, okay, the results that I got were this, and you as a parent, right, come along and say, well, you know, I don't believe that the teacher did the experiment or something. Would you have to do the experiment again?
If you want to be scientific, yeah, or at least give them the means to do it again.
Okay.
If you say, sorry, it's all hidden knowledge and, you know, you keep that secret, then that's science.
And then what if another teacher, what if all the teachers of the 10% come along and say, okay, not teachers, the parents of the 10% come along and say, okay, we need to see you doing that experiment again. Doesn't that eventually just become a waste of time?
Not if you record it and post it.
But video can be doctored, or
that's the pain in the ass of science. Sometimes you have to do things over and over again.
Or a good example is when I did the potato core thing. That's not something that we could have simply recorded with a.
Like I said, that's the pain in the ass of science. Sometimes you just got to keep doing it over and over again. You got to keep repeating it.
I think that there gets to a point when repeating it, if you're getting the same results, right, and someone says, okay, well, I want to make sure that your results are correct, right, and you keep on repeating it for them because maybe you're the only person with a particle accelerator, right?
You don't have to keep repeating it for the parent. You can give them the information for them to do it themselves, and if they opt not to do it, that's their own ignorance that they're walking into, or that's their own ignorance, which is, hindering them from knowing the truth.
Well, let's say
you don't personally have to keep showing every parent who keeps coming in to dispute it.
Let's say that it's something to do with a particle accelerator, right? Like,
all right.
Which is very hard. Like, not everyone can get access to a particle accelerator. At some point, if someone keeps on asking, okay, I want to see this, I want to see you reproduce this experiment, I don't know if there's an experiment that takes a long amount of time, but you might have an experiment, like, let's say there's an experiment that takes 80 hours with a particle accelerator, right?
Okay.
Or even, I'm sure AB Science can give me an example of something that takes, like, 80 hours, just videoing it.
Whatever.
Isn't really going to work.
Sorry to be in a rush here, but yeah, let's just see it once. Because if they can't show it even once, it's not science. If they can't show it once and have the forethought in today's age to at least record it, to save them the pain in the ass of having to do it over and over again, then it's not science. It's just exciting sounding information.
Oh, I disagree. Like, if something takes
Well, it doesn't matter because it doesn't satisfy the scientific. It doesn't satisfy the method.
Well, the thing is, like, if let's say I have a particle accelerator, right? I can do it takes 160 hours, and I can, I only have the opportunity to do it twice, right? Right? Once, once to be able to check the conditions, and the second time just for verification, right? It takes 160 hours. And you come along and say, well, you didn't record it. And I'm like, well, you want me to record 320 hours of video?
Yeah, science is hard. Yeah,
you want me to record 320 hours of video showing me?
Yeah. Yeah, if you want to actually say that you completed the experiment and that you did it scientifically, you're going to either need to do it again or give someone else, the information to be able to repeat it. Because if it's not repeatable, it's not science.
Now, a peer review person can come along, right, and use a particle accelerator. They can go ahead and verify.
If they actually watch the entire experiment themselves, or if they conduct the experiment themselves, yes. If they're just reading some other dude's data and saying, yeah, that sounds cool, there's no criteria in the scientific method that says take some dude's word for it.
Well, peer review is where you actually repeat the experiment, unless, of course, you cannot repeat the experiment.
My point exactly, which is, are they actually doing the experiment?
I think that, I could be wrong about this, and I'll see if I can. I don't know if AB Science is still around. I think he had to dip, but
that's right. I had a great time, and I'm sorry, man. I'm so bummed. I got to let you go, but there's a kid. I don't know if you can hear. There's a kid yelling in the other room, and I got to go take care of it. But
okay.
For you and your audience, I always love it. I have a great time when we're going back and forth together. But my apologies. I got to run.
Yeah, all right. Take care.
Thank you.
Yeah. All right. See ya.
Bye-bye.
Bye. Oh, we got. All right. Yeah, you can't. All right. There we go. Oh, that was the core issue there. I think was his. Yeah, why isn't he? That's a good point. Like, why didn't I ask him, why aren't you doing any of the experiments? Like, these experiments to show the shape of the Earth can be done. I think his core thing there was, and this comes down to a lot of what a lot of flat earthers seem to get at, is the very rigid. It's like the solipsism. It's like, okay, we've got to do it myself, right? The issue that you get down to there is it comes down to a point where if you're doing everything yourself, right, there is no way that you don't have time to advance anything. Like, I think that science... Oh yeah, I need to read super chats, don't I? Viewer activity... jeez. He was so traumatized by a teacher not trusting him and demanding a video of the experiment, never gotten over that. Possibly, yeah. Like, I think that the data collection is good evidence. Now, it is possible that the data collection is all fraudulent, right? But that's very small possibility. And when you've got the whole, when you've got like a lot of people eyes on you in the scientific community, I can guarantee you that you'll have like 30 people in the room with you. Right? If you are, like, let's say that you're at the LHC, right? I can guarantee you that there's going to be many people in the room with you, making sure that you're getting the results. In fact, I'm sure that there'd be things in the computer to say, hey, look, these are the results that we got, so that you can't go, okay, I'm gonna just fudge these results ever so slightly. the permanence of data is a problem. Yeah, like I think that's his issue. Like he considers that when the experiment ends, the experiment is no longer there in the minds of the people that weren't there to view it or see any recording of it. I think that is an issue. I should have actually used like space travel as an example. Like that would have been a great example. Like you've got videos of NASA employees when the Perseverance rover lands on Mars, but he's not going to trust that. Right? And the question, like, if you've got the Perseverance rover landing on Mars, you've got videos of the NASA employees when it lands on Mars. You've probably got some videos of NASA employees, with the drone thing that goes on Mars. You got video of them, having the elevation. Now, if you doubt that it's going to happen, that it actually happened, people will go through all the videos and try and find one small problem. However, I don't think that's the way that you should do it. I think that when there's 30 people, if you got 30 people in a room that are all watching it to verify it, and then you got someone else in the room that watches it and verifies it, maybe doing a different one, 30 other people that do the same thing. I think that's conclusive enough to say, hey, look, this is probably legit. There's also the p-values, right? You have to at the very least a basic understanding of these. You have to have a basic understanding of the subject before we can even start to understand these experiments. Demanding to see the experiment. Yeah, that's why It's actually very hard to find these experiments, right? Unless you know the key words that you're looking for. Because, for example, if I bring up this here, this thing here about the core, right? It's National Geographic. It's National Geographic. It doesn't really. What's the... it tells you what things mean, but it doesn't really... Yeah, it says geoscientists think... is there anything about experiments done here? Oh yeah, here's a good thing. Geoscientists cannot study the core directly. All information about the core has come from sophisticated reading of seismic data, analysis of meteorites, lab experiments with temperature and pressure, and computer modeling. Most core research has been conducted by measuring seismic waves. That's what I was talking about. The shock waves released by earthquakes near the surface. The velocity and frequency of seismic body waves changes with pressure. Now, that is a good explanation. I'd take that and go, yeah, that's good enough for me, right? However, what he wants to see the actual experiment. Right? And where do you find... you got a whole lot of PBS, National Geographic stuff, but where's the actual experiment? I prefer to go by papers, right? If someone can give me a paper on stuff, I'll be happy to read it. I mean, hell, I've been reading a few interesting papers recently. Let me just, whilst we're here, I might as well go to youtube.com. There's a video that I want to watch, posted 14 minutes ago by Friendly Geordies. He's not as, I will admit, when it comes to, this is, I should probably actually bring that over here, just really quick, so I can go to monetization and go to super chats. There we go. Back here. Alrighty, see you all. Alrighty. We've got the Spirit for $10 saying, if I say something is blasphemy and a lightning bolt hit me 99.9% of the time, I would conclude a god. I wouldn't have faith that they exist at that time. There would be evidence one or more exists. Yeah. Like, if I think that it's one of them things where there are extraordinary occurrences, right? Like, if I said, hey God, if you exist, make lightning happen. Like, make lightning and thunder happen right outside my house right now. Now, if that were to happen, it hasn't happened. But if it were to happen, that would be a bit of evidence that God might exist, right? If I did it again and it didn't happen, there'd be evidence against God existing. It's all about the magnitude of evidence, and at least to me it is. It's about the magnitude of evidence. How many people have done the experiment? That can sometimes be a factor, right? Like, if heaps of people have done the experiment and they get the same results, then yeah, that's a good thing. If a couple of people get an opposing result, that'd be interesting, but it would be, I have to be very careful here, because sometimes it's one of them things where this doesn't really contradict anything that I've said in the past, does it? Because I'm thinking back to last week, where I had someone in my chat that gave me like 6 links. It's like, I'd rather have one really solid link than like 6 somewhat dubious links. But like, it doesn't really contradict that, because if like 1,000 people have done it, then yeah, that's really good evidence. That's like one solid link right there. But yeah, like, if something has happened, there's been studies to do with prayer, for example. I think it's actually a good example. There's a particular document that I need to check about. It's to do with puberty blockers. There's like something to do with puberty blockers, and like apparently there's like a really good, like, there's Cornell, it's like the Cornell study. I know about that, and I can easily find the Cornell study. Is this? Oh yeah, so there's the Cornell study, which was a huge analysis. It was like a big analysis saying about gender transition. I'm just trying to think. Okay, I need to try and find the particular one that I'm thinking of. But anyway, like, a really good study is like that's why we've got meta-analyses, right? Meta-analyses basically go through all the studies and go, okay, well, this is what they say. Because, it's better to have one really solid link than 1,000 like little links. And basically a meta-analysis goes ahead and takes all those little links that show something and it analyzes them all together, rather than analyzing them separately. Because if you analyze something separately, you can get biased results. Anywho, you've got Indie Tiger for $20 US. Thank you, Indie Tiger, saying, as a civil engineer, I can tell you that we use different wave propagation techniques to determine what is underground. Explosives, electric probes, sound waves are all used to find things underground. I did think about bringing something up as well. When measuring fault lines, I know that they sort of send waves, like they use like some technique that sends like waves down and waves are reflected back to find certain fault lines. Would germ theory be a good proof of the problems with peer review at times? What do you mean by that? I'd have to, like, if you could elaborate, please do. So yeah, like, that's how they find fault lines, right? By using like echolocation, and that brings it back to like, what is that? Like, that's at the end of the day, that's data. But if you go ahead and reproduce it, you're going to get the same data. You're making inferences based on the data. Like, sometimes I think that it's okay to make inferences based on data. I really do. You can shoot me for that, right? Like, I don't think that experiments is... Like, at the end of the day, I don't think that experiments is the end-all, be-all. I think that you can make inferences based on data. Like, if I see a book on my shelf, I'm not going to experiment to make sure that it's made of paper. I'm just going to be like, oh yeah, it looks like it's made of paper. It's paper. It's a paper book, right? I've got the Harry Potter series on my shelf. Not only do I have the Harry Potter series, but I have, like, Quidditch Through the Ages. I think that's what it is. Yeah, it's Quidditch Through the Ages. Goes to show how little I've read of that book. I shouldn't say that. Like, I do need to get around to reading. There's a couple of books that I still haven't read that I should. Anyway, just because I haven't experimented to make sure that it's paper doesn't mean that it's not paper, right? And likewise, I can tell you people that have seen those books on my shelves, and they can go, yeah, this person has books on his shelf. Like, they're there. I don't need to turn my camera around and show you the books on the shelf. I can go grab the books and... Well, I could go grab the books and show you, but then it's not on the shelf, is it? Blackburn Big Dragon says, I imagine that these florists wrote "nuh-uh" on their maths test and answers in school, and then they argued that F is the genius grade and everyone else failed the tests. I'd actually be very interested to have a discussion with him on maths. Like, it seems like be interesting to have a... Like, that would be one of them sort of non-confrontational discussions, right? Like, I doubt it would be very confrontational. People said you get sick because of... Oh, okay. Because of the spirits. Yeah, yeah, that's something that, yeah, is definitely... I think that I'd have to see when we last believed that, because I do know that, like, it was the... Because there is an extent to how much things are true. Like, going back to the whole experiment thing, there is an extent to how much things are true. Like, if I, for example, I could say that miasma effect was one of them things, right? Bad smells cause sickness. That was one of the ideas that that was big. Now, that isn't completely wrong. It's true enough to actually be useful, right? And I think that's a lot of what things are. Like, they're true enough to be useful. Like, the whole model of the atom, right? That's true enough to be useful with the whole different shells and the electrons are spinning around. That's not how it is. It's more of an electron cloud thing, right? But you can use, like, when you're using chemistry, you don't need to know about quantum mechanics to be able to do your chemistry based on, like, the electron shells having, like, an individual electrons rather than, like, an electron cloud. And by electron cloud, I mean like a quantum cloud of electrons where there's actually just one electron, but it's a wave function thingy. Very complicated. Right, like what I was saying with the Ken, or actually I use something. When did I say it? Where did I say it? Did I say it for Ken Wheeler? I don't think so. There's something when was it? It was a while back. I've said a lot of things. Like when it's true enough. You need a very basic understanding of quantum physics for chemistry. Very basic. Well, to an extent of like you don't need an in-depth understanding is what I mean. Like you don't need to know, okay, like there's an electron cloud. You just, at least to my knowledge, that's like you don't need that, right? Like if you go, okay, this is an electron cloud. Or at least from what I've done in chemistry, all you need to do is understand, hey look, there's valence electrons. Atoms like to have a full shell of valence electrons. Why they do this doesn't matter. I like how people are quoting me in chat. Like I've said a lot of things. Planarwalk 2021, and I see that Shills v Shills has gone. Like that's fun. Like got a good chat. Anyway, more super chats. Graymore Ghost for $5 says, ahoy hoy. I see you've got a real winner on your hands today. Why do you torture yourself? So sorry. Like, honestly, Flattening Atheism isn't so bad. Like, I can say good things about him. Flat Earth is super. Did I say that spirits make you sick? I think it's probably... it's Right the Hand. Video I made on Right the Hand, it would have been. That's it. I said, yeah, like, it's good enough explanation. And then he took that and ran with it. That's what I was thinking of. Alright. But yeah, Graymore Ghost, like, he's not as bad as other flat earthers. I'd much rather have a conversation with, honestly, if I had to have a conversation with anyone, I'd have a conversation with Flattening Atheism, rather than having a conversation with, Austin Whitsitt, for example. I'd much rather have a conversation with Flattening Atheism than Flat Earth Aussie Jesus. At least, with Flattening Atheism, there are some things that we can agree on there. We don't agree on everything, but we can at least agree on some things. Whereas Flat Earth Aussie Jesus, he will be like, my own experiences. Like, you could... Should I do it? Should I organize... I wonder if I should. Like, should I organize a debate between Flat Earth Aussie Jesus and Flattening Atheism? I'd be... Like, I'm gonna poll... I'll probably have a poll on my community tab, but for now, I just want to... Like, if there's... Like, just about, like, science and stuff. It would be very funny. Like, let's... It'd be, like, it would be very funny, like, to see... In Flat Earth Aussie Jesus versus T-Jump yesterday on Modern Day Debates, FEA ended up saying that stars are the glowing spirits of people who lived good... Jesus Christ. Okay, we've got 70... Like... I would be on board to have this, because like I'd just be moderating. I'd be like, okay, Flat Earth, because like Flattening Atheism, he's very respectful. Honestly, like Flat Earth Aussie Jesus can get very combative. We've got 77% for yes, 13. But it's gonna be interesting to see. There's a video of a flat earther claiming all stars are nest. You need to send that to me. Like, okay, the reason why I haven't uploaded any videos this past week was because wisdom teeth, very painful to. It's getting better now. Yeah, it doesn't feel like painful anymore. Does anyone have that annoying thing where the wisdom teeth like bite the back of your mouth? That's the reason why this past week I haven't uploaded anything. Also been working on other stuff as well, which was fun. But yeah. Anyway, oh yeah, we've got super chats. Indie Tiger for $10 says, prove to me right now that your video experiment for your teacher you use soap and water and pepper. Prove it to me right now. Yeah, like it's one of them things where he probably doesn't have the video. Like, I'm going to... Combative is a nice way of saying that FEAJ can be a raging sexist asshole. Yeah, that is true. It is a nice way of saying it. I don't want to kill this debate before it happens. I actually am... I can't vote in this poll, but I'd vote yes, because I want to see this. I need to contact Flat Earth Aussie Jesus. How do I do that? I might have his... I was going to say arsehole, but... his email. I get the feeling that like that can be taken way out of context. Like... Adam L says, why are you pretending you are not getting bald planet? Well, bald is beautiful. I have luscious hair, right? I am growing luscious hair. It does need some shampoo, like it. But I was gonna wash it yesterday, but like the shower was like really cold. Anyway, yeah, like so I brush it instead. I'm growing luscious hair, like it's gonna be really long eventually. I'm gonna grow it longer than I ever have. I would kill to get Hans Wormhat to debate FTFE. That would be beautiful. I think that I actually wonder how FTFE would do for moderation, like because FTFE has moderated a couple of debates. How? Because if FTFE and I both moderated a debate between Flat Earth Aussie Jesus, like firstly, like that would be a dumpster fire, right? Like Flat Earth Aussie Jesus and FTFE in the same place. That's a dumpster fire, right? I'm not cutting my hair. I'm gonna have luscious hair, and I've even got a hair straightener. Like for if I want to. FTFE, yes, would. Maybe not get FTFE to moderate it. Like, should I get FTFE to help me moderate, or should I just, let them go at it and have my own form of moderation? Because like, I can be a bit slow on the uptake of moderating sometimes. Like, I do prefer to give people verbal warnings and later go on to mute them. Like, if they keep on ignoring the verbal warnings, I will mute them afterwards. Like, in previous debates that I've moderated, it's generally been one of them things where I haven't been able to do much, unfortunately. Craig wants nothing more to do with Flat Earth Aussie Jesus. Fair enough. Yeah, I'll just have organised a debate if they want to. It'd be very interesting. I love the thought of like getting two people that are in general agreement to disagree. I love the thought with that. So AT2 Productions says, Planarwalk, we need a glamour picture of that luscious hair whilst you're on a deck. And you better read this aloud. Done. MC2 and Hans Wormhat debate. That'd be interesting. Anyone think a debate with Nathan Oakley where he's just muted the whole time would be hilarious? It would be. I actually, I believe I can say this. So I actually found out about the Nathan Oakley versus Cats debate that never happened. I actually found out about it before Nathan Oakley even mentioned, or before Nathan Oakley was even told about it. Kind of. I essentially had a sneaking suspicion that it was going to be Cats, and I'm getting better with that pronounce. Thank you. I had a sneaking suspicion that Cats was going to be in it. Mostly because I was like, yeah, get Cats. Okay, I'll have to check Facebook. I don't usually go on Facebook. Nathan versus Cats. Nathan basically ducked and dodged. I sent Cats a message saying, because Cats sent me a thing about that video that that song that he was doing about the balloon. I don't know if I should. I'm sure Cats wouldn't be too disappointed if I were to show you like because it actually had a different ending and oh, okay. It actually had a different ending. Like it's on my phone somewhere. I'm sure Cats wouldn't mind me showing you the alternate ending to the original. Well, to the actual one, to the final version. Yeah, so where is it? And if you can tell Cats and who can complain. Have you debated with Jason and Ronnie on Awakened Souls? No, I haven't. That'd be interesting to debate, though. Okay, here we go. So if I go right to the end here.
No. Yes, I will. Yes, I will. But it's a balloon, so it won't go down too. It doesn't go down! Okay. Screw you then.
So yeah, that's that was the original ending. So yeah. Anyway, I asked him about the debate, and he was like, wait, how do you know? And it was because the guy had contacted me. I hope everyone heard that. I hope it wasn't too loud as well. But yeah, like, I was essentially like, yeah, get Cats in, because like Cats would be better for this. Anyway, Design Song 1 says, of course, it's okay to make inferences based on data. How else would you use a map? Is driving the whole world around the only way to trust a map? Science to trust. So I think I know what you're saying here. So I think you're saying that like if you you got to trust that the maps you got to trust that the maps are correct, don't you? And I trust that Google is going to get me to the place that it's going to get me to, right? And there are times when it won't work, but it works. Entertain Us was the song like you did last week. Yeah, I could do so. What is? Oh, did anyone recognize that thing that I was playing at the start? The whole. Shit. It's easier to play. I'll just take my headphones off because it's easier to play with, I guess. But yeah. Anyway, I'll just finish up my thoughts on the whole map thing. Yeah, Google Maps doesn't always work. Like in China and places, it doesn't work. But in New Zealand, America, it's going to work. I trust that it will work wherever I am planning on going. I don't plan on going to China, but if I were to go to China, it'd be different. Different story. But you know this because people have said. Anyway, does anyone recognize this? Having played the piano for a while, horrified by it. Yeah, I'm not a good piano player. Like, hold on, let me switch to I'm terrible at playing piano. How do I? I'm trying to think of a song that I can kind of play. I haven't. You should circuit bend that keyboard. What does that mean? Like, I do have a. I can actually. Raise your arm a little. The fingertips should touch. Oh, so like. That might help. Let me think of. It's like. I'm trying to think. Oh, something like. Sometimes I find it very hard. Like, if I play guitar, it's really easy to. Like, even then, like, I've been trying to get a particular song. It's not Jurassic Park theme. Oh yeah, I'll switch over to camera. Like, even then, like. I haven't gotten this far, so it's something like. I'm not sure how that part's meant to go. Does anyone know what song I was playing there? Super. It's everyone's favourite song. It looks like. If I were to tell you the lyrics, you'd be like, "Oh, never gonna give you up, never gonna let you down." I butchered it by singing it, but there you go. Just for your information, you just got rickrolled by Planarwalk of all people. Yes. Yes, you did. What's another song that I can play? Oh, there's one that I was learning like last night because like I was like, oh, okay. It's like the bass line to a song, so this like should be an octave down. So it's so yeah, that is Living on a Prayer by Bon Jovi. That one there. Oh, the thing that I was playing before, by the way, the whole is spoilers for WandaVision. I never get to grips with these grips. Respect Planarwalk. What do you mean by that? I'll end the poll, by the way. We've got 31 votes, so that seems like a good Stairway to Heaven. We got okay. YouTube Studio does this or not? Can I pay you to stop? I can play some good things. Like, wait, how does it? Why isn't? Oh. Why did I suddenly forget? That's... I saw... Oh, YouTube copyright strikes. Yeah, that is an issue that can sometimes happen. Oh, there is... Oh, I wonder if anyone can get this one. There's two versions. I'm going to play the acoustic version. Where did I put a pick? I have... like, oh, there's some picks here. Which pick do... Like, these picks are terrible. Like, I've got this oversized pick here. I've got this oversized pick. I've got this pick that I made. I used to use like these like super thin picks a long time ago. Like they're like 0.46 millimeters and 0.38 millimeters. Like really super thin. Playing on guitar is subject to copyright claims though. I got, like, every time I play on the guitar, copyright claim. If I play it recognizable enough. That's why probably not a good idea to sing what I'm playing. But, what's... Okay, here we go. And then there's the other version, the... Like, it's really hard to get, like, the whole... Because it's like... And then, like, the up here version is, like... I've forgotten that I used to know it. What are people saying? Green Day. Oh, I know a few of them ones. Let's... So yeah, there's that one. Like, everyone should know that one. And then it goes to a thing where it's like... Wait. I'll play some Black Sabbath. Okay. What ones do I know of them? Everyone should know that one. I did a little switcheroo. You thought it was Iron Man, but then I switched into Paranoid. Hey. Someone said Nirvana. Do you know Mood for a Day? No, I don't know any Yes. I have heard of one song by Yes called Roundabout, but I haven't learned it. That would be a great song to learn. Oh, actually, one song that I was playing recently. I was on a voice chat and someone turned out their name was Polly. It was... Cool. Even seen Erwin Dobson's song called Time Tour. There's a song that... there's a song that I could... there is one song that I remember playing. It's like... Hold on, I can go to... Wait, I just thought of this song. Here we go. It's like... Okay. everyone knows that one, right? Apparently it's like drop D. I didn't know that. Or at least the version I'm looking on here is. What was another one? Paint It Black. Goes back to the other thing. Like, you got the guitar that... I like this sort of rolling guitar in the song, the whole... I see a red door and I want to paint it black. No colors anymore, I want them to turn black. I need to play with your tinfoil hat on. Oh, there's also another one. Like someone said, it needs to. You need. They say it goes this way, but it made me think of. How does it go? Shit. How does it go? Something like that. Been a while since I've practiced. Like, I'm playing a whole lot of songs right now that I haven't practiced in ages, maybe not even years. Like, what's another song that I haven't played in like a long time from memory? No, that's... I can't remember. Like, anyone else I'm gonna like end up in like 2 minutes because the thing. But anyone else got any suggestions? Oh, I know someone said like last time Red Hot Chili Peppers, so something like that. That's the other side. I know a few of them, like... Okay, one last one, and then I'm gonna end the stream up, okay? So, I just had a thought of this, this one. Hope people recognize it. It's the intro to a song. it goes onto the hole. But yeah. Wonder if anyone recognised it. It's not Megalovania. It's the intro to a song that, like, Megalovania is like okay. Anyway, I'm going to head off because basically there should New Zealand government should be live now, but but yeah, leave a like and subscribe if you like the stream. Leave a comment letting me know what you'd like me to do for future streams. I'll see if I can get in touch with Flattening Atheism, see if he's willing to do a debate with Flat Earth Aussie Jesus. It'll probably be about something to do with Flat Earth and something to do with science. it'll be something. It'll be interesting. The poll says yes, so yeah. Anyway, I'll see you in the next stream or video between you and me. Thank you for watching.